For the next part, we are asked to find the standard deviation, okay? So in this case, we have a sample, okay? So we need to find the sample standard deviation, okay? And we have the formulas here. The formula is said the square root of the sum of each value minus its mean, everything power 2 divided by the how many numbers, which is sample size, minus 1, okay? But be careful with this part, okay? It might look scary, but it's actually not, okay? This means that it's the subtraction of each item minus the mean, and then power 2. So we're gonna graph each of the values, okay? And we're going to subtract the mean or the average, and then power 2. And then we're gonna add all of those results. Okay, so let's do that. So let's do like a mini table here. So we're gonna put our x values, which are gonna be each number here. The next we're gonna do each number subtract by the mean, and then we're gonna do the power 2, okay? So let's do that. So we're going to start. So we don't need to put them in order. It's up to you, but that's gonna take a lot of time. So let's put 98 here, okay? 92, 5, 93, 98, 94. Okay, so let's start with this one, okay? So we're going to use the calculator, okay? So it's basically each number minus the mean. Remember that the mean, let's go back here, okay? And we found the mean to be 91.25, okay? So let's go back and let's write it here. The mean is 91.25. We found it in the first step of the problem, okay? So 98 minus 91.25, and then we're gonna power 2 the value, okay? I'm just going to show you the whole work for the first one, and then we're just gonna do the rest. Yeah, because the rest is the same thing, except for 98, we're gonna put 92 and then minus 91.25, and then power 2. When you use a calculator, you should get 45.5625, okay? Do not round it off, okay? Do not round up. I think that for 4 significant figures, or for 4 decimals, that should be fine. But do not round off to the first or second, okay? The safe spot is the third or fourth, but fourth for sure. Now, I'm going to do it for the rest, okay? And you will see the whole list of numbers. Okay, so once we get that, right, please make sure that your calculations are correct, because one number, you will mess everything up, okay? So let's use a formula, okay? Before that, let's find the sum of all of these numbers, because that's what we need, okay? And the sum is all of these, okay? This, if we find the sum of all of these, that's exactly this notation. And that's what we need, the sum of all of these calculations, each number minus the mean, and then power 2. That's what we did for every single one of the numbers, okay? Now we need to find the sum of all of them, okay? So let's do that. So the total come out as 862.25. Okay, I'm going to double check this again, okay? After double checking, we indeed get the same answer, okay? Okay, so let's follow the formula, okay? The formula says standard deviation is everything under the square root of the sum of x minus x bar power 2 divided by n minus 1. Okay, so s equals the square root. So this notation here is this one that we just found. So that's 862.25. Everything divided by, remember that we have sample size is 12, okay? So it's gonna be 12 minus 1, which give us 11, right? So let's first find the inside, okay? Let's divide 862.25 divided by 11, because that's 12 minus 1. That gives us 78.3863, and then 63 keeps going, okay? So we could stop there. That should be fine. Now let's take the square root of that number. So give us 8.85360738, okay? Which it's a lot of numbers, so let's leave it with 4 decimals, okay? So 1, 2, 3, 4. So we're gonna cut it there. And we look at the following number, which is 0. So 6 will stay the same, okay? Remember the rule, okay? Of rounding off numbers. If the next number is 5 or more, then you move this one unit up. This one right here. If not, then you keep it the same. So our standard deviation is 8.8536. Or if your professor wanted to one decimal place, that would be 8.9. Or 8.85. That's okay as well. I double check with my calculator, the TI-84 calculator, and we get the same exact value. Okay,